Hey there, it's Chris, and we are taking a look at questions 23 through 25 in Section 4 of SAT Practice Test 3. So for question 23, this is a question that has a pretty challenging and lesser known concept being tested, but a question that if we do know that concept, the math on it is actually not going to be too bad. So let's talk about the concept first. Here they show two angles, and they say the angles shown above are acute and sine A equals cosine B. And for this, I'll color code this in red and I'll put it down here as an identity to memorize. But the relationship, when you have two acute angles, the sine of x is always equal to the cosine of the complementary angle, which would be 90 minus x. And so whenever that's the case, this identity, another way of saying this is if you think of a triangle, any right triangle that you have is going to be, if you look at these two angles, we can call them x and y, but just understand that y in this case is really the same thing as saying 90 minus x. It's the acute angle. Since we have a 90-degree angle, the sum of the other two angles have to add up to 90. So in this case, you can also think of this same identity as sine x equals cosine y, and vice versa. You could switch the order around on those. It would be the same thing as saying cosine x equals the sine of 90 minus x, or cosine x equals sine of y. So however you see it written, it's still the same identity. I actually do recommend memorizing all four versions of this. So I would maybe highlight all of that as something you want to make a flashcard of or add to a Quizlet, because as long as you can recognize this identity when it's being shown to you, which is exactly the case in this question, instead of a and b, instead of x and y, they use a and b for this particular problem. But if you can recognize that relationship, if the sine of a equals the cosine of b, this is a fancy way of telling you that a and b are complementary. Or another way of thinking of that numerically is that a plus b would have to equal 90 degrees. And that's all we need for this question. So I'm going to make this a little bit smaller and kind of move it off to the side, but that's definitely the key identity. You want to make sure that you memorize that. And so on a question like this, if you do have that memorized, then they're basically saying that these two expressions will sum together to 90 degrees. 4k minus 22 plus 6k minus 13 equals 90. Combine like terms, 10k minus 35 equals 90. Add 35 to the other side, 10k equals 125. Divide by 10, k will equal 12.5, which is going to be answer choice C on question 23. So while this may look intimidating at first glance, if we know that identity, this question becomes something that we can answer relatively directly. It's just one equation with one variable where we can solve for k. Up next, we'll take a look at question 24. Here, it says Mr. Cole has a beaker containing n milliliters of solution to distribute to the students in his chemistry class. If he gives each student 3 milliliters each, he will have 5 left over. In order to give each student 4 milliliters each, he will need an additional 21 milliliters. How many students are in the class? Well, this is going to be tough to try to answer algebraically. It's doable, but it's tough. Let's see if we can take advantage of our answer choices here. We have 4 answer choices, so let's test one of them out and see how we could use that to our advantage so that we don't have to come up with this algebraic expression on our own. So for answer choice A, to answer the question of how many students are in the class, let's try plugging in 16. Let's see how that works. If there are 16, if he gives each student 3, will he have 5 left over? Well, let's see. So if you have 16 students in the class, and you gave each student 3, so 16 times 3, that would be 48. And then with 5 left over, that would be 48 plus 3. I'm sorry, 48 plus 5, which would be 53. So this would mean that Mr. Cole had a total of 53 milliliters. So this is like solving for n. For answer choice A, this is like saying n is 53. All right, well, let's see if that works out to match our second statement. In order to give each student 4 milliliters, he would need an additional 21. Well, let's try it. So if each student, 16 students, were to get 4 milliliters, let's see what that would multiply out to. 16 times 4 is 64. He has 53. Is that an extra 21 to get to 64? So we can check. If you do 64 minus 53, that would only be an extra 11 milliliters that he would need in order to provide each student with 4. So that doesn't work for this particular question, because, or this answer choice, because 64 minus 53 is not equal to 21 for that one. So we can say no to answer choice A. And let's minimize this, and then we're going to take a look at our other answer choices. So we'll go one by one here. Let's try answer choice B. Let's say you had 21 students in the class. So 21 students times 3 milliliters each would be a total of 63. And then the 5 remaining, so just like we did for answer choice A, that would give us 68. Now, that's our total. That's our value of n. And let's see if we had 4 milliliters for each student. So that would be 21 times 4. And that comes out to a total of 84. And is that 21 more milliliters? Well, let's subtract and see. 84 minus 68. That would be a total of 16 extra milliliters, which we can say is not our correct answer. It's not equal to 21. We're trying to get 21 there. So we can say no to answer choice B. Move this off to the side and test out answer choice C. If we have 23 students in the class times 3 milliliters each, that multiplies out to 69 milliliters. If we add on the 5 remaining, that would be a total of 74, which would be our n value for this one. Now let's see what it would take to give each student 4 milliliters. That would be 23 times 4, which would be 92. And is that an extra 21 milliliters? Well, let's test it out. 92 minus 74 equals 18. Not quite 21. We're getting closer, but this is not equal to 21, which means it's not answer choice C. And it is, in fact, going to be answer choice D. Now, on test day, you wouldn't take the time to do that calculation since you've already eliminated the rest. However, just so you can see the work here in the notes, if you had 26 students times 3 milliliters each, that's 78, plus the remaining 5 that they mentioned. That's 83 total for your value of n on this one. And then if you needed everyone to have 4 milliliters, 26 times 4 would give you 104. Is that an additional 21 milliliters? It sure is. 104 minus 83 gives us 21. This one checks out. It is, in fact, answer choice D. Lastly, from this page, we have question 25, which has this figure, and it says a grain silo is built from 2 right circular cones and a right circular cylinder. So we have the cones and the circular cylinder with internal measurements represented by the figure above of the following, which is closest to the volume. So we need to break this up into parts. We have volume of a cylinder, which is going to be pi r squared h. I highly recommend memorizing that. However, if you don't know it, that will be provided at the beginning of the section with your formulas. Here, the volume of a cone is going to be 1/3 pi r squared h. And the volume of this cone down here is going to be the same thing. Same formula, 1/3 pi r squared h for that one. So we are basically going to have to just do the volume for each of these individual pieces and then add them together to figure out our total volume for the silo as a whole. So let's plug in our numbers here and see what we get. So for the cylinder, this would be pi times our radius, which is 5. So pi times 5 squared. And then times our height, which they show us is 10. So times 10. And when we do the math on that, so 5 squared is 25, and 25 times 10 will be 250. And so we have 250 times pi. And if we look at our answer choices, do they leave everything in terms of pi? Oh, shoot, they don't. It's in terms of the actual decimal representation, so we would have to multiply 250 times pi, or 250 times 3.14, and when we do that, 250 times 3.14 comes out to be 785. So this is going to be 785. I bet if you did the exact math, my guess would be if you used pi all the way to an infinite number of decimal places, you'd get 785.4, since that's one of the answer choice options, but we're not done. It can't just be this 785 amount here. We also have to add on these cones from the ends. So for one of the cones, we have our volume is equal to 1/3 pi times r squared. It's the same radius. This has a radius of 5, so times 5 squared, and then times the height. So the height of one of these cones, they show us 5 feet, so times 5. And if we do that math, we get 25 times 5, which is 125 pi divided by 3. And when we do the math on this and multiply it out to get an exact decimal, we get 130.83 repeating. And that's for this cone on top, and hopefully we can recognize that this cone on bottom is going to have the same radius, and if we take a look, it's same radius and same height, which means it'll be the same value. This volume for this cone down here will also equal 130.83. So if we add those two plus the 785, we come out with a value around 1,047, and that matches up with answer choice D. So this question involves some complex calculation, but luckily the SAT will give us all of the equations necessary for us to plug in and solve. And here we're basically just going to add together these three values: the 130 for the volume of the cone on top, the 130 for the volume of the cone on bottom,